we are here looking at 4.8, which has to do with Earth's geography and climate. This is just a little diagram that you're seeing with California droughts over the span of a few months. Pretty scary stuff. All right, let's move on. So we know already that the planet can be divided up into different climates or biomes, climate regions, whatever you want to call them. And you can see on this map here, you're looking at it in terms of tropical, subtropical, temperate, subpolar, and polar. And all of that has to do with the different wind patterns and convection cells and ocean surface currents. So it's all kind of getting tied together here. Like I was just saying, what determines these different climate patterns? Convection currents and prevailing winds, which is part of global air circulation. Ocean currents, and whether they're carrying warm water or cold water. And then also the tilt of the Earth, whether whatever hemisphere we're talking about is tilted either towards or away from the sun. And those are your three big factors that are affecting climate. And then what all of that means is the last thing down here, is that heat and precipitation are unevenly distributed. Some parts of the Earth receive more sunlight than others. Some parts of the Earth receive more precipitation than others. That's what we're talking about here, is temperature and precipitation patterns. And we get these different patterns because of the amount of solar energy that's being received on the Earth. It's pretty straightforward. So as far as what we're talking about here in this section are the ways that different geographical features can affect climate. And what I want to focus on are two different geographic features. Mountain ranges and how mountain ranges affect climate, and proximity to water. I'm actually going to do the water one first, even though it's listed as number 2. So if you look at the map over in the left-hand corner, you can see we are comparing climates at the same latitude, comparing the cities of San Diego and Phoenix. And if you look at San Diego, their colder temperature or coldest temperature is at 9 degrees, and their warmest temperature is at 24 degrees, comparing winter to summer. And then looking at Phoenix, 5 degrees versus 41 degrees. And I am giving you the temperature in Celsius. It's also listed on here in Fahrenheit. So notice which one has a larger range of temperature. That would be Phoenix. And the reason for that is that anywhere inland, not just Phoenix, but any city or location that's located further away from an ocean is going to have more variation in temperature between like winter and summer, or even daytime and nighttime. Because if you are in a city that's situated next to a large body of water, like the ocean does a great job in helping to moderate our climate. The ocean absorbs a lot of that excess heat. The ocean is essentially a heat sink. So what that means is in the hotter summer months, the ocean water itself absorbs a lot of heat from the atmosphere, helping to cool things off. And I'm sure you've all experienced a sea breeze before, if you've been anywhere near the beach, helping to keep things kind of cool. And then in the winter months, the ocean releases all of that stored heat that it had accumulated. Not all of it, but it releases a lot of that stored heat that it had accumulated over the summer, warming the air in that coastal town or coastal city. So coastal places, like we'll just say Deerfield Beach, their climate, or San Diego in the case of this map, their climate is more steady throughout the year, because in the summers, the ocean absorbs a lot of the excess heat, and then in the winters, the ocean releases a lot of that excess heat, kind of preventing, I should say, the temperature from fluctuating too much. So if we're talking about a place that's like smack dab in the middle of the United States, then they're going to have big fluctuations between winter and summer temperatures because they just don't have that regulating effect of the ocean. And that's what you're seeing in the map there, comparing coastal San Diego versus Phoenix, which is located more inland. They're at the same latitude, so they're receiving the same amount of sunlight, but the big difference is that San Diego is near the Pacific Ocean, and so the ocean water itself is helping to regulate the climate. So that's all I want to say about proximity to water. And then the other one that's on this slide are mountain ranges, which is what you're seeing in the picture here on the right. You are looking at something referred to as the rain shadow effect. And I'll explain it in just a second. Here are 4 more pictures, all showing the rain shadow effect in some way, shape, or form. But essentially what you have is an ocean and a mountain. That's kind of what we need for the rain shadow effect to take place. So, the winds are coming from the ocean and blowing towards the land. That is called a sea breeze. As the winds are blowing towards the land, those moist winds, because again, they're moist because they were blowing over the ocean, picking up moisture, those moist winds run into the side of the mountain. And essentially what happens, they travel up the mountain, and that means that the air is going to get cooler as you're traveling higher up in altitude. As the air cools, the liquid in the air condenses to form clouds, and then the clouds, once they are saturated, release that liquid in the form of rain. So the side of the mountain that is receiving the brunt of the wind, which is called the windward side of the mountain, is a wet side because, again, the moist wind runs into the mountain, and then essentially what happens is that wind kind of goes up the mountain, the air cools and condenses, or the liquid cools and condenses and comes down as rain. So one side of the mountain has a very wet climate, but on the other side of the mountain, which is known as the leeward side of the mountain, the air is much drier and you get desert-like conditions on the leeward side of the mountain. And that's what the rain shadow effect is. That's what all of these pictures are showing somehow, some way, is that you've got your wind picking up moisture from the ocean. As that wind approaches the mountain or the windward side of the mountain, that moisture that is in the air cools and condenses high up in altitude. When it cools and condenses, it comes down as rain or maybe even snow. And then on the other side of the mountain, the leeward side of the mountain, now our air is drier and it can pick up a little bit of heat from the sun, and we get that side being in a rain shadow, which is the drier side of the mountain. And so that's just another example of how certain geographic features can affect the climate of a region. And those are the 2 things that we went through, were the rain shadow effect and proximity to an ocean. That's quick and easy, and that's it for this section of 4.8. Please let me know if you have any questions. Bye.